Hey, Jonathan here at Colfax Math. This channel is all things math. So a lot of math applications. If you like it, hit like and subscribe, and hit the bell if you want weekly notifications. I teach high school math in shop, and I love math for the beauty of it, but also for the applications of it. In this video, I'm going to go over square roots, how to add them, subtract them, rationalize the denominator, a few different pieces to square roots. And one thing I'll say about square roots is they're really important because if you understand the rules of square roots, you also understand the rules of algebra. So the rules of algebra, combining similar terms, is the same for square roots. Okay, so before I go over square root, I'll go over the forward operation. Square means you take that number and multiply it by itself. So 6 squared means 6 times 6, and then you multiply that together to get 36. So the function is squaring. The reverse function of squaring is square rooting. So this is saying what times itself equals 36. So the square root of 36 is equal to 6. But negative 6 times negative 6 also works, is 36. But a lot of times you just forget the negative because you're looking for the length of a side. So that's what a square root is. The other thing I was going to say as well is the difference between exact versus approximate value. An exact value means without a calculator. So this is an exact value, the square root of 2, versus if you entered that on your calculator, 1.4 times 1.4, I think, is equal to 2. So that's an approximate value versus an exact value. And just like square roots are really key to identify the rules of algebra because they're so similar, this idea versus exact and approximate is also really key because standardized tests usually want the answers in exact value. The advantage of an exact value answer is the reader could take that root 2, an irrational number, and enter it in their calculator and keep as many significant digits as they want. On an approximate value, they don't know where you rounded to or if you rounded correctly. So an exact value is usually a better answer. It is also the answer that's usually on a standardized test. So exact values are frequent because they really test conceptual understanding. Okay, so now that we know what an exact and approximate is, we're always going to try and go towards an exact. A square root is saying what times itself is equal to that number. And it might be a perfect square like 36, but it might also be a non-perfect square like 72. The way you simplify this radical here, root 72, is you look for the factors of 72. You could see that, say, as a 9 and an 8. And what I'm looking for here is pairs. I'm not going down to the primes of that number. I'm just going down to pairs. So 72 is a 9 and an 8. A 9 is a 3 and a 3. An 8 is a 4 and a 2. A 4 is a 2 and a 2. And then for every pair, one comes out. So here's a pair of 3s. One comes out. Here's a pair of 2s. One comes out. There's no pair for this 2, so it stays in. So root 72 is equal to 3 times 2, 6, root 2. So that's an exact simplification of that square root. But let's say you saw 72 not as a 9 and an 8, but rather 36 and 2. 36 is a pair of 6s. I don't have to go all the way down to primes because now I have a pair. For every pair, one comes out. No pair for that 2, it stays in. So it doesn't matter how you factor that number as long as you bring it down to pairs. Okay, so that's a general idea of simplifying square roots. Let me go over a few more pieces to them. Let's say I have a square root of, say, 11 thirds. Well, that's equal to the square root of 11 over the square root of 3. The thing about this is I'm dividing by an irrational number. Right, this number, square root of 3, goes on forever, so I don't divide by a square root, so I need to simplify that. So the way I simplify that is I take square root of 11 over the square root of 3. This is an expression, not an equation, so I can't do whatever I want to both sides because there is no both sides. I can only multiply it by a factor of 1 so as not to affect the value. So I'm going to multiply it by root 3 over root 3. This is equal to 1. Root 11 times root 3 is root 33. root 3 times root 3 is root 9, or just 3. So now I have a rational number in the denominator, and that's called rationalizing the denominator. By multiplying by a factor of 1, I get the square root out of the bottom of it, and this is a good answer to have. It's pretty common on standardized tests to have an approximate value comparing it to an exact value, and even though they seem the same, they might be off by 1 or 2 decimal places. The exact value is always a better answer. Okay, and then next we have adding and subtracting square roots, and it's just like algebra. X plus y is equal to x plus y. So root 3 plus root 2, I can't combine dissimilar terms, is root 3 plus root 2. However, if I have x plus x, what I'm saying here is I have one x plus another x, so now I have 2 of these x's. And that's the same thing here, root 3 plus root 3. Well, I got one of these things plus another one of them, so I have 2 of them, or 2 root 3. Let's say I have root 72 plus root 8. They're dissimilar square roots, so I can't add them, but I could simplify them first and then see if the roots are the same. So like we did before, root 72 is 36 and 2. Pair of 6's, one comes out, so root 72, the equivalent is 6 root 2. Then on the root 8, I have a 4 and a 2. Pair of 2's here, one comes out, and then one stays in because there's no pair for that one. So root 8 is equivalent to 2 root 2. Now I have 6 root 2 plus 2 root 2, so what I'm saying is I have 6 of these things plus 2 of these things, or 8 of these things. So that's how you add. Subtraction's the same. If I had root 5 minus root 3, they're dissimilar terms. I can't do anything. That's just root 5 minus root 3. But if I had 7 root 5 minus 2 root 5, I'm saying I have 7 of these things minus 2 of these things, or I have 5 of these things. I could multiply them together as well. So root 7 times root 3 is root 21. And that can't be simplified because 21's a 7 and a 3. They're both primed. If I have radical 8 times radical 3, I could see that's equal to root 24. 24 is made up of a 8 and a 3, 4 and a 2, 2 and a 2. Here's a pair of 2's. For every pair, one comes out. There's no pair for this 2 or this 3, so they stay in, so it's 2 root 6. And that would be your answer. Okay, that's a quick overview of simplifying radicals, adding and subtracting them, the difference between exact and approximate value, rationalizing the denominator. Hopefully that'll help you on a standardized test. This is more of a quick review for a standardized test than it is an actual lesson on square roots. But I'm hoping that makes sense. If you like the video, hit like and subscribe. I appreciate you watching, and I'd love to hear your comments below. Thank you.